In this video, we are going to look at java.time package. The java.time package contains classes designed to handle date and time operations in a modern, thread-safe, and more intuitive way compared to the old java.util package. In the Cupcake app, we use the calendar class defined inside of the java.util package. Using this calendar class is no longer recommended, so instead we are supposed to use classes defined inside the Java time package. So we're going to learn how to use them. So first, if you want to learn more about java.time, you can Google java.time and the result will take you to the java.time package documentation. So you should see something like this. Here you can see there are multiple classes and enum classes and exceptions. I'm not going to explain each and every classes, but instead we're gonna look at some classes I think are more useful and you would use more often. Let's start with LocalDate, LocalDateTime, LocalTime, and ZoneDateTime classes. Once we start using these classes, you would notice all the classes defined inside the java.time package sometimes use the same method name. So if you knew what a method did in, let's say, LocalDate class, chances are it does the same thing in LocalDateTime class. So let's start using them. I'll be using the IntelliJ IDE. So this is not Android Studio. With this, I can run Kotlin scripts. So as you can see, I'm already have some lines of codes written. I'm using LocalDate and LocalDateTime classes, LocalTime, ZoneDateTime. And also notice all of these classes have now method. To demonstrate what values are generated, I'm going to use the debugger instead of println function. It would be much easier and it wouldn't clutter the screen. So let's set a breakpoint. So I'm going to set it here and let's run the debugger. So the value generated like this, these values are what you get when you call a toString method on this. So the object. So essentially, when you call now method on this class, you would get a LocalDate object. So the returned object as a toString method. So when you pass this expression in a println function, you would get a result like this. This is the string you would get on the output. As you can see, the result uses the current year, current month, and current day. So that's the local date. And also notice the LocalDate time uses the date as well as time. So the time part is after the T, letter T. If we click on that date time object, we can see that it has a date object and a time object. So this is the time object, right? When you call local time now, it returns a local time object. When you call local date time, it returns both date and time object. So the time is 15, so it's in like 24-hour format. So this is the hour, this is the minute and seconds, nanoseconds or whatever. Okay, so this is the last part is the nanosecond. And then zoned date time. So this is a date and then time and nanosecond. And this is the offset value plus 5 colon 30 is the offset value. And then Asia/Calcutta is the region. So this is where I'm located. I'm in Asia, but I'm not in Kolkata, but this value is used to give us the local time. When you use the now method, it creates an object with the current date, time, all this stuff. So if you wanted to pass custom values, you would use of method. So every classes have of method. You can already see what this expects. It expects a year, month, and day of month. Oh, day of month is like 17. Okay, now let's check date time, local date time class. It also has a of method. This is how you would set values to these classes using of method. You can't use the constructor. So you can't pass values to the constructor because the constructor is, well, it's just private. So you can't use it like this. Instead, you got to use the method for setting the values, getting the values. You always use the methods. So this is all the overload it expects. Local date time expects all these overloads. Year, day of month, hour, minute, second, nanoseconds, all this stuff. If you look at the local time, it also expects hour, minute, and nanoseconds. These are all in integer. And it's the same story for the zoned date time, I think. Okay, this expects year, month, day of month, hour, minute, second, nanosecond. And then at the end, it expects a zone. So now we looked at how to pre-populate all the fields with current date and time. And then we also saw how to pass in custom values using the of method. So if we take a look at the what now method expects, you can see it expects a zone and a clock. This zone parameter expects a zone ID, and this clock parameter accepts a clock object. Zone ID is basically used to offset the time from the UTC. You might be wondering, what is UTC? UTC is a time standard used as a reference point for measuring time around the world. It serves as the baseline from which all other time zones are defined. UTC time is always the same wherever you are in the world. Countries use UTC to get their local time by offsetting hours and minutes from UTC. These offset values are based on the combination of geographical location, historical factors, sometimes political decisions. So I live in India, right? To get the local time used in India, you need to offset UTC by plus 5 hours, 30 minutes. Okay, UTC is cool and all, but how do you create zone ID? You can create a zone ID by calling the of method of zone ID class. So zone ID of. For the of method, you can pass two types of IDs: fixed offsets, geographical region. So what's a fixed offset? As you can see, when we ran zoned date time with now method, it generated all of these values, right? So this part plus 530, like I said, this is the value used to offset UTC to get the local time, right? So this is the fixed. This value is used for the fixed offset ID. It kind of looks like plus 2 digits for the hour, colon, and another 2 digits for the minutes. So if you use like this, it's wrong. So instead, you gotta use like this. This is one way to create the zone ID. You can also prefix it by saying UTC. This also works. I believe there's another way. There's another prefix you can use. So let's say if we wanted to search for the Japan time zone, it says GMT plus 9, right? We can also use the GMT plus 9. So let's run it. Now the time says 19, but currently for me it's 3 p.m. So that's like what, 15. So 15 hours. So the Japan is like 2 hours ahead. So the another way is by using the geographical region. You use the fixed offset if the country doesn't observe any daylight savings or the offset stays same throughout the year. For example, India doesn't observe any daylight saving throughout the year, so I can just use the fixed offset. But if there's a country that do observe daylight saving, you're better off using the geographical region ID. So how does this ID look like? It kind of looks like this, continent/place. So when we first ran the zone, let's run it again and see. Okay, as you can see, this, when we first ran, it uses both the offset value and the geographical region ID. So this is how the region ID looks like, right? So this is the constant, this is the continent, and this is the place. When you use the geographical regions for the value, Java automatically offsets from the UTC and also takes care of daylight savings or whatever by using internal rules. You can find the region names that Java supports by calling this function. Okay, let's run that function. Okay, if we do run it, it kind of looks like this, right? Asia/Eden, all of this. So there are like 603 items. It doesn't really say which country though. So these values are referred to as time zone identifiers. You can look this up on Google to see what country that is. This will probably take you to the Wikipedia list of TZ database time zones. Okay, now we can see, well, we have a country code and then we have the TZ identifiers. And then we also see the offsets, time zone abbreviation. Okay. So it uses the country code to list all the TZ identifiers. So you might want to know what these country codes mean. For example, the United States uses US as the country code, right? So it's probably somewhere here. But anyway, we need to use values like this. So I looked at this. The Japan uses Japan as the region ID. So we can just go here and say Japan. So if you make a typo or use something that isn't defined inside of this zone rules provider, you get an error. As you can see, you already see an error, unknown time zone ID. Like I mentioned, every now method expects this zone ID, clock object. Time also expects. So this is just to get the local date based on the offset values. So when you call the now method, it uses the region you have set inside of the settings of your operating system. So I am probably have set region to India, so that's why it's using the India. If I have set it to something else, it would probably use that when we call the now method. If you want to override this behavior, you can pass the offset values or region IDs. Okay, now let's start using some of the methods these returned objects have. So I have already listed some of the methods these objects provide. So if you read the documentation, some methods start with get. So this get method is used to get a value. But in Kotlin, we can omit using the get word. So instead we can use it like this. So here we have a get date of day. Here we have a day. So here we have a get day of month. I can just use day of month, but notice that it starts with a small letter instead of the capital letter. So let's set a breakpoint somewhere here and remove it so we can see all the values generated by the compiler. So when we first called the LocalDate now, it created this object with these values. So we have 24, 11, and 17. So when we call day of month, we got 17. Month value, that will be 11. So November. 11 is for November and 12 is for December. So if we wanted to get the November, so the value just November, we need to use there's no way to get the value. So if we access it, there's no way to get the name of the value. So instead, we need to use the month class and then we use the from method, and then we need to pass the LocalDate instance. So we are passing the LocalDate instance to the month from, and then it creates a month enum class. If you notice that Java time package, you can see that month is actually not a class but enum class. See, this enum class has all this enum subclasses. So we can create a enum month instance by just passing LocalDate object, and this LocalDate object contains a name, ordinal, and as. Notice that this ordinal is 10 instead of 11. This is because in Java, months January is 0, February is 1, and all the way to December is 11. That's why it says it's 10. Okay, let's move on to the day of week. So day of week just says Sunday. Day of year, this returns how many days have been passed. The era is CE, which stands for Common Era. And the year is 2024. Okay, so basically, if you use the get, this is the value. So you can probably tell what these values mean by just looking at this, right? So this is not that hard. So let's look at some methods that start with. So let me set a breakpoint here. So the current value is set to the same thing. And then with day of month. So these with methods basically replace the values you provide to them. So with day of month replaces the day of month with 1. So it was 17 before, but now it's 1. With month replaces the month value with the provided value. So before it was 11, now it's 1. With year replaces the year. Before it was 24, now it's 23. With day of year replaces the day of year with the value you have provided. So it just recreates the local date object using the day you have provided for the day of the year. So day of the year just means how many days have been passed from January 1. So essentially, this date is the 100th day in this year. Let's now look at the methods that starts with plus. So plus days, plus months, plus weeks. As you can tell, it does what it says. It adds these days, months, weeks, and years. Again, so this is the value that is generated. So if we use the plus days method, it adds 5 days. So when we add 5 days, it becomes 22. When we add months, it becomes, I just added 1 month, so 11 becomes 12, plus weeks, same thing, it adds weeks. So when we add 1, it just adds 7 days, right? And then years, it adds a year. I have added 1. Okay, this is the year, right? This one's the old value. This is the new value. When I added a year, you can see it changes to 2025. Also, this local date and all these objects also come with minus, methods. Minus days, minus weeks, minus years, minus month. All of this does what it says. It subtracts the provided values. So the methods we looked at, get, with, and plus, minus, can also be used with the local date time, and zone date time. So it has minus, plus, right? And then this also has that plus, right? So I'm not gonna go over using the local date time or local time classes. So I went over the methods pretty quickly, but you can usually tell what a method does by just looking at it. The method names are pretty verbose, so I hope you can easily figure out what each method will do when you use it. But if you don't know what a specific method does, just by reading it, you can read the documentation of the class, and that might help you figure out what that method actually does. We looked at how to create instances of these classes using the current values or using custom values. We also saw how to access individual fields like what day of month it is, what week it is, what year it is currently, all this stuff. But what if you wanted to display these values in a nice string like this? You would think you need to embed these field values inside of a string using a $, curly braces, something like this. But don't worry, there is a class you can use to create date strings just like this. The class I am talking is called DateTimeFormatter. This formatter takes a pattern, and with this pattern you can create strings like this. So let's take a look at how to use this class. So I have already written some code. So the DateTimeFormatter as a off pattern method. This method takes in a pattern. So this pattern is used to create those strings. So what is this pattern anyway? So to learn about what patterns you can pass to this method, you need to open the documentation of DateTimeFormatter. So this is the documentation page for the DateTimeFormatter. This is where you can learn more about patterns this class expects. So these are the patterns. This pattern looks like letters from the alphabet. So we have G, U, all this stuff. So these methods, these letters are kind of like placeholders for the actual fields. For example, this Y letter is a placeholder for the year. So if you like use this pattern, so wherever the Y letter is, the actual year will be substituted in its place. So we have like day of the year, day of the month of the year, day of month, all this stuff, right? So month of the year, like this is the name of the month. So July. There's also like number, and there's a number padded with 0, and then there's a name that's shortened a little, and then there's a full name, and then a name that's just indicates a name that's really short. So these letters you can like use more than one occurrences. So if you scroll down a bit, you can see some rules of what it means when you use more than one occurrences of the letter. So the count of pattern letters determines the format. So less than 4 pattern letters will use the short form. Exactly 4 pattern letters will use the full form. So this is what they mean. So this is the full form, I think, and this is the short form. And then exactly 5 pattern letters will use the narrow form. So this, you can read all this instruction on your own. So this just tell you how many occurrences of letters you can use. So if you use more than the allowed occurrences of letter, you will get an error. So let me create a simple pattern. So I want to create a string that kind of looks like this. So the first value is day of the week, and then the day of the month with the th at the end, and then a comma, and then the year. So how do we create this? So first we need to figure out what's the letter used to for the placeholder for the day of the week. So let's see. So I think we can see this is the one, day of week, and then there's also another one, localized day of week. So let's use the day of week. I think to use the full form, we need to use like more than one occurrences of the letter. Let's figure out as we use it. I'm gonna first use 2 letters, and then we need to use the day of the month. So let's look at what is the value. So day of the month, we used D. So D. What happens if we use a th, and then comma, and then year? For the year, we can use the Y. So let me also use more than one occurrences. I am hoping that it will use the full form. So we just need to, we need to use this pattern. So I have a LocalDate object I created using now method. So it creates a it uses current date. So every object, every date object has a format method. For the format, we can pass in this format, DateTimeFormatter. So let me just call it format. I'm gonna put it on top. So okay. So let's use this format. Let's see if we get an error or not. Okay, we actually got an error. So unfortunately, we can't use any letters other than the formats. So one quick way to just I think use like this, surrounded with single quotes. Let's see what happens. So if we just use the if we just surround it with single quotes, it doesn't like think it's a pattern. So instead, uh, it just replaces. So it just embeds this th string. So these four e's created the Sunday, and then the d replaced the d with the day of the month, and then the next. So and then the th is just embedded right after the day of the month value, and then we have a comma and then year. So we managed to create this. So there are other patterns you can use to create a different format. So different formatted date strings. But just remember that if you like use placeholders for like time, you need to pass date time object. If you use placeholder for something that uses zone patterns, you might need to pass the zoned date time, or else it wouldn't work and it would complain. So that's just how you can create formatted date strings. Not only can you format strings, but you can also parse date strings. So the LocalDate object has a parse method. So this parse method takes in a string and a formatter, which is just a datetime formatter that's used to create the string. So if we let me just copy this. So if we wanted to create a local date object with just this string, we just need to pass the string, and then we need to pass the pattern. So let me use the format. So when I run this expression, we get an error. Although we managed to create custom string easily, but if you want to parse back, if we want to parse back a string to a local date object, we need three things. We need a year and a day of month, and then the actual day, right? And then we need the month. So it has year, the day of the month, but it doesn't have the information for the month. So we need to somehow add that information, or else we can't parse back the local date object. So here I'm going to put em, but it still can't parse back the, I think, th. For the em, let's say 1. I would be surprised if it managed to. I think it did parse some values. Okay, when I ran this code, it says the day of the week is 3. In this date, the day of the week is what? Monday, Tuesday. So the day of the week is Wednesday. So it's the 3. But I am using the 7, which is Sunday. So we just need, let me just say change it back to, okay, this should probably work. It managed to parse back it managed to create the local object if we just pass in all the required values, year, month, day of the month. So if we don't provide any of the values required to create the local date object, you get an error. So if I leave out the year like this, let's see what happens. So we probably get an error, right? Because it can't. So the day of the month is 17, month of the year is 1, day of week is 3. but it couldn't find the year. So that's why we got an error. So if we put back the year, it can easily parse back the object. It can easily parse back the string. Okay, we saw how to format date strings, and we also saw how to parse the date string. So there's one more thing I need to cover, which we used in the Cupcake app. That is the NumberFormat class. The NumberFormat class in Java is used for formatting and parsing numbers and currencies and percentages in a way that adapts to different locales and formats. So let's start using it to figure out what that means. Okay, let's try formatting numbers. So if we wanted to format numbers, we use the getNumber instance. If we wanted to format the currency, we use the currency instance. And if we wanted to format percentage, I think there's also a method for that. Where's that? Okay, percentage instance. So let's try the getNumber instance. Okay, this as a format. Let's see what it expects. So this expects like a double, a long. Let's try passing in some numbers. Okay, so if we look at the number, we can see that I only passed a number that doesn't have any like commas or anything. You can see the digits are separated by commas now. So the number is formatted as numbers would format. So the numbers are formatted as in US. So in the US, they separate digits every like 3 digits, right? But if you wanted to use another country's formatting conventions by passing the locale. So the number format getNumber instance, this method expects a locale. So you can see by pressing Control P what parameter it accepts. In locale parameter accepts a locale. So locale object. We can create a locale object by using locale. You can also see there's predefined locales. So Canada, China, France, Germany. So when you use this locale, these numbers will be formatted how the numbers will be formatted in those countries. So I don't see India, so let's create our own locale object for India. We can use the off method. This off method takes in a language and a country. For the language, I'm going to use the English. For the country, I'm going to use the IN. So this is the country code. So when you pass a custom locale object to the number format, it doesn't format the number correctly. As you can see, so in India, these last 3 digits are grouped, and the next 2 digits are grouped, and the next 2 digits are grouped like that. So here they always group 3 digits. That's not how numbers are formatted in India. So I think it only happens in this IntelliJ IDE. But if you use this in Android Studio or in Android apps, it correctly formats the numbers. Okay, so this is a Cupcake app we built in the last video. So I'm gonna be using this. So the subtotal value is responsible for displaying this number. So this is as a string. So the subtotal just expects a string, and we're passing the price of the cupcake as the string. But I'm gonna use the number format, and we're gonna pass that as a string. The number format get number instance. We can pass a locale like we did, and then we pass in some numbers. As you can see, now it's correctly formatting. But this wasn't the case when we use the IntelliJ IDE. You can also format currencies. So when you use the currency instance, you get a currency symbol like here, and then it also has a percentage instance that expects a decimal. You can see it converted the decimal into a percentage. The only reason you would use this number format is because, well, it formats the numbers and currencies in a local aware way, and then you can use this to parse those strings. I'm not going to show you how to parse this. I'm not going to show you how to parse the string in this video, but I hope you can figure that out on your own. Okay, that's pretty much it. But in the beginning, I said we use the calendar class and date object when we built the cupcake app. So I want to show you how. So I want to, modify and update the project to use the latest Java.time classes. So we need to go to the view model, and this is it. This is the one. It's using the calendar. So instead we need to use the local date. So we just so what's this? So the Monday, November, like this, right? So we need to use the date format. What's that? So we need to use the other date format, not this one. So first let's use the local date. Okay, we're gonna add the whatever the thingy is, and then we need to use another formatter, date formatter. Maybe it's called date format. Okay, it's called DateTimeFormatter. We need to use the off pattern. For the pattern, we're going to use this. Looks like this world function expected a local object. Let's see if this. Okay, this new datetime format. So this new datetime formatter also expects a local object if we wanted to provide it, but we're not going to use that. Now we just need to use the local date object. Local date object. I have assigned it to date variable. So date variable contains the format, and we just need to provide the format, which is this datetime formatter. And then we just need to increase the day by 1. So we just need to use the plus days 1. So that's pretty much it. Let's see if it works as expected. So it's not increasing the previous value. So this just returns a new LocalDate object. We might want to assign it. Okay, there we go. Anyway, that's pretty much it for this video. In the next video, we're gonna learn coroutines. That one's gonna be a toughie, but I hope we can get through that. Until then, see ya.